responsibility. And that kind of struck me, and I was like a kid, I said, well, why? Why is it our responsibility? And I kept asking why, and he said, because we are creating, with the help of even our competitors, technology that is revolutionizing how data is viewed, how data is used every day in our lives. And it's our responsibility to help these nonprofits that are trying to do good for humanity to leverage their data as well, and to help them keep up with all the trends that are happening and be a part of this revolution that is happening right now as we speak. And that really resonated, not just because I like the fact that we're doing good, but because I've been using this slide as an intro slide for a while now, for 2 years, and I always thought this was just a marketing slide, and I always struggled with it. And that conversation last week really resonated in the sense that it is real. What we're doing with data right now is changing so significantly that it's affecting all of us in many, many ways. And I hope today that you'll get a sense of where it is in your life. I want to start out with one of our customers. One of our customers here is OPower. And OPower is using Hadoop and Cloudera as the foundation, because Hadoop is the infrastructure that provides the way to store and find data in a big data environment. And OPower is using Hadoop to help you, consumers, understand how you use energy. And so if you have a flat or a house and you are using heating and electricity and gas, this device here, the smart meter, helps you understand what your trends are. It even helps you turn it on and off and things like that, and helps you save money. And as a result, utility companies in the United States are offering discounts to those consumers who actually use this same product. And so in addition to helping you, better utilize your energy and save money on your bill, you're actually getting a discount as a result, because it's saving the utility companies money as well. And all in all, it's also reducing the carbon footprint of everyone utilizing this tool that's based upon Hadoop. And that's one of the exciting things about where we're headed with data. It's products like this that are really changing the way we do things and the way we think. And big data is everywhere. It's in every sector, every industry. I was just sitting in this room. I was looking at the data that was just around in this room. I saw people on Facebook. I saw people watching a little movie. I saw people on the internet on their mobiles. There's a surveillance camera right outside. There's a Wi-Fi that's tracking logs and simulating that data. There's all kinds of data just right here in this room. And if you walk outside, there's even more and more data being generated. And it's everywhere. And companies from every industry are utilizing this data. And I'll talk about just a few. One you probably are really familiar with. So it's in the media and entertainment industry, where Netflix, for example, I might recommend a movie. There's also companies out there that will recommend books or music. Spotify, you've probably heard of. All these things are using Hadoop and big data underneath the covers. And they're aggregating data from all over the world and from various means, from social media and from your responses, your sentiment when you write comments or posts on the internet. And they're simulating that data and providing you as a consumer better service. Another one that you might be familiar with is marketing and advertising. Maybe some of you are planning a trip in the summer. Maybe go to Croatia or something. You book a flight or you book a train ticket. And the next thing you know, you're getting an advertisement on a hotel or a tour guide in that same location or the general area. That's because Google uses big data. They actually help create Hadoop. And they already know what you're doing, and they're doing very targeted marketing. And same with Facebook. If you post on Facebook a picture, you in the Austrian Alps, you're probably going to get some advertisements related to where you are. And that's because they're doing very highly targeted marketing that's all using Hadoop underneath the covers. Another example that you might not be as familiar with is automotive industry. So you might be driving your car and a beeper goes off because you're driving too fast behind a car that's in front of you. Well, how do they know that? Well, what they've done is they've analyzed data from all of their cars that they produce. These automobile manufacturers have collected data, and when there was an accident, they understood what happened. And they've assimilated that data and programmed these sensors to better alert you when something's happening. And then you have companies like Tesla who are taking that to even new lengths, where the car even knows where you're going before you get in the car, just based upon where you are and the time of day and what day of the week it is. So we're seeing advances all over the world and all over every industry, and it's all using technology such as Hadoop. But one question I almost always get when I have a presentation like this is, why is data so suddenly big? I mean, haven't we always had data before? What's different now than 10 years ago? And there's four main things that are really different. One is you all are using your mobile phones all day, every day, right? And you're reading the internet and you're posting on things, you're posting on social media. And all this stuff has happened over the past 10 years. And before, you probably had to have a laptop or a desktop and you were at home and you had to wait till you got there. But now you can do it while you're waiting on the tram. And all this data is being analyzed as clickstream data and can be useful to companies. In addition, I saw someone taking video earlier. And so it's so easy right now with these devices to take video, to take photographs, and to post it. And there's also technology that can analyze all this data. I saw on the news today how there's an application in Russia that can capture your photograph at a concert and immediately identify you with 70% accuracy. It's amazing. But this technology and the ability to create this data has all happened within the past 5 to 10 years. And you see here this chart that comes from the IDC, and data has essentially doubled every year for the past 10 years. And that's why all of a sudden data is big. It's because we have all of this unstructured data, right, that is not in the form of a relational database and tables and things. It's in random different formats. A better name for it might be multi-structured, in the sense that it's in a defined format, but it's changes depending on what data you're working with. And so data has been doubling over and over every year for the past 10 years. And that's what's created this phenomenon, and as well as this revolution that we're part of. One thing that you might find interesting is this relational part looks rather linear, and there's a reason to that. So up until Hadoop came along, and even today in most companies, the established way to work with data at this size is really called data warehousing. And there are four real big problems with data warehousing. The first one is cost. So data warehouses are usually based upon big servers such as Oracle licenses, and they're usually using high-class hardware, such as a NAS or something that's very, very expensive. We estimate that the hardware that supports a data warehouse costs almost 100 times the hardware that is needed to support Hadoop. And so when you're faced with this budget issue, that's a significant difference in price. Most companies, when they have a data warehouse, they have to make a decision about what data is relevant to them. And so cost impacts what data they can look at and what data they can keep. So the big cloud of data has now become a box, and they have to stay within this box. And it's very hard for us to know we know what we need today, but it's really hard for us to know what we need tomorrow. And that's a real fundamental problem with data warehousing. Another problem is that in order to get the data into a data warehouse, what happens is you have a business analyst, and what a business analyst does is, they're trying to answer a question like, how do I recommend a comedy TV show to someone who just watched Game of Thrones? What information do I need to do that? And so this business analyst will work with their engineers to come up with a set of relational data tables inside of their data warehouse. And they work with them, and they finally get their data loaded into their data warehouse, and they get the answers to their questions, hopefully. If not, they have to iterate over that. That's a huge bottleneck. because you have to figure out how you want your data to look before you even know whether or not you have the answer to your question. And those of you all, a good analogy is if you're writing code for a project or something, and you make a code change, then you have to wait 2 hours to see what the results of that code change is. That's not very fun, and you're not very productive. And that's a lot like what the transformation process in data warehousing is. So what do? You figure out a faster way because you want it deployed in 20 seconds or 30 seconds so you can immediately see the results of your code change, right? So that's what companies do. They create what's called small data silos to work more efficiently, more effectively, further reducing their data set on what they're looking at, and also duplicating data across the whole company, making it chaotic and pretty much impossible to update and upgrade. And so enterprise data warehousing is fundamentally flawed in that way. And finally, it was never designed to handle petabytes of data that companies are now working with. So that's what companies are doing now, and it's really the established way. But Hadoop is a modern architecture that brings the ability to really analyze all of this data in a much better way. First of all, it's affordable. I mentioned that it's 1/100th of the cost to buy hardware to support Hadoop. In addition to that, though, it's very, very scalable. So you can quickly add nodes to your Hadoop cluster without really having a lot of effort. It automatically adds them as simple. It's also a centralized area because you're not having to make decisions about what data is important to you today. You can put all of your data in this one data lake, is what it's called, and you can keep growing that data lake over time, and you don't have to make those decisions about what's important to you and what's not. And the other advantage is it's accessible. So those business analysts who had to wait a long time for their data to be transformed so they could get the answer to their question about, what TV show should I recommend to this client, now it's very accessible to them. The data lake is right there, and there's all kinds of tools in which they can use to quickly get the data. And it could be in a raw format, it could be in a database format. It doesn't really matter because the transformation process was completely eliminated. And finally, Hadoop was designed for this type of data set. Doug Cutting, who works at Cloudera, originally was part of the Hadoop founders, and he created Hadoop because he and some friends at Google and Yahoo were trying to index every single page on the internet. From the very beginning, they thought about having a need for a huge amount of data, and so Hadoop was designed from day one to accommodate large amounts of data. And even better, Hadoop is an open platform. Okay, so what does that mean? I mean, you can see all the various open source products that have come out since 2006. This spec was only 2 pieces. It was a storage, HDFS, and a compute, which was MapReduce. And now there's over 30 components that make up the Hadoop ecosystem. And because it's an open platform, you have the whole community that's innovating, not just Cloudera, but our competitors and our partners are all innovating in this. Facebook is an example of another contributor to Hadoop. And we're not even in the same business, Cloudera and Facebook. And so you have a lot of companies that are contributing to this. Facebook had a problem. They had a lot of SQL developers, and they needed people who could get data out of Hadoop. So they created a component called Hive, which is right here. And Hive maps SQL statements to a MapReduce job. So a programmer didn't really have to know how to write MapReduce jobs. All they needed to know was SQL, and they could get data out of HDFS, which is the old storage unit for Hadoop. And what enabled Facebook to do this was that it was an open platform. I mean, you can't really go write a huge module that has such a significant change to an Oracle or an IBM product. I mean, this is an open platform in which any company or even an individual can contribute. If you have a feature that you want to write, you can do that. You just have to interact with the community and tell them what's the justification for that, and they'll accept your change or a bug fix. And so this product is going to continue to evolve. It has some bad things that come along with that, but it's also highly innovative. And that's one of the great things about Hadoop. But it's not all rosy, okay? So this is an interesting one. Gartner, they're business analysts in the United States. 60% of big data pilots are going to fail, not this year, but next year. So it's probably even a bigger number for this year. 60% of big data projects, pilots, so not even the big ones, are going to fail. 90% of deployed data lakes will be completely useless. So what does that mean? It means we're still very, very early in this technology curve. So this curve is something that's studied in business school. And we're right here, just leaving the early adopter stage. So most of the companies that are finding value from Hadoop are considered early adopters. You know, same thing as the people who bought the very first iPhone model or the very first Mac. You know, a lot of times, like, I'm still thinking about the Google Watch, but I'm not an early adopter. I'll wait and see if people really like it. You know, so you have companies that are willing to be that, but most companies aren't. And so that's why you see those statistics, because we're still so early in that technology curve. And there's a lot of advancement that has to occur. But there's also a lot of activity. This chart, which you can't even read, is a chart that a Silicon Valley investor put together that really shows all the companies that are involved with Hadoop in some way. And it's a lot of partners, a lot of vendors, a lot of application developing companies, and there's a lot of activity. And that's the really good news, is that curve is going up, that there's a lot of contributors to the Hadoop ecosystem that are innovating as part of this open platform. And before I go into this next thing, I want to talk just a little bit about what we can expect moving forward. So we're going to expect a maturation of the platform. So the infrastructure has really been developing over the past 10 years. Hadoop itself, the infrastructure that Cloudera sells. But as that matures, you're going to see more application layers being developed and very fine-tuned solutions for different industries. And also, there's a lot of I guess artificial intelligence is the old term for it, but machine learning is the new term that's happening right now, to allow companies to really learn from that data lake that right now is kind of useless, because they have put all their data there, but they really haven't figured out how to learn from it. And so in the next couple of years, we're going to see a large increase in machine learning and talking and hearing about technology around machine learning. And these are the trends that we're seeing right now in big data. And I want to end it with another really exciting, I guess, customer of Cloudera. And healthcare is a really big industry for Cloudera and for Hadoop. There's a lot of data that can be captured with healthcare. There's information about human genes. There's information about illnesses and medicines, and it's massive amounts of information. And we have one customer, Cerner, that has been doing two things that are really huge advancements in healthcare. The first one is that they're studying patients who come into a hospital with a condition, and their diagnosis, they're looking at their diagnosis, and they're looking at when they were released, how long they were in the hospital, and why they were released. And then they're looking at, was that patient readmitted back to the hospital? Because that causes a lot of problems. One, it causes churn in the hospital, inefficiencies, which raises the price for all of us. And it also is uncomfortable for the patient if they get sent home too early. And it can cause health problems if they're not supposed to be sent home. And so Cerner is doing this analysis to really figure out what's the probability that you're going to be returning to the hospital based upon your condition and your diagnosis and your current situation. And in addition to that, they're sending some patients home with a monitoring device. So Internet of Things is another big boom thing right now. And it has a cross-section with Hadoop because it collects data, right, that then has to be analyzed. And Cerner is sending home people with monitors that track what's happening in your blood. And they're able to detect sepsis or blood infections much more quickly than it would happen if you came down with some sort of symptom and then had to go to the hospital, which is saving lives every day because blood infection is a very common way for people to die after they're released from the hospital. And they're using Hadoop and big data to accomplish this. And it's companies like Cerner that have me really excited about the future of data and where we're headed with Hadoop and big data. And that's all I have today. Do you have any questions or?
Any questions? In that case, thank you very much for the presentation.